Hello everyone, welcome to MRU E-Learning powered by Malla Reddy University. I am Afroz, working as Assistant Professor in Malla Reddy University in the Department of Cybersecurity, IoT and ECE. I am here to present the topic on Embedded AI. So Embedded AI plays a vital role in the modern IoT and smart systems. So here, what is Embedded AI? Embedded AI is nothing but enabling the intelligent decision making on the devices. So let's get started. So here comes the outline of my presentation. First we start with introduction and then about edge computing. So here, before going to discuss about embedded AI, edge computing is the main thing. So what is edge computing? So computing itself is processing the data. Edge computing is processing the data at the edge of the device. The name itself says the processing the data at the edge of the device. So here, what is the edge of the device? In a network, the data source, we call the data source as the edge of the device, or else we can call it as a sensor. So here, edge computing, first we'll discuss about edge computing, then embedded AI, how this edge computing is combined with embedded AI, architecture, applications and advantages. So first, what is edge computing? The name itself says edge and computing. Computing is nothing but processing the data. So here, what is edge computing? Processing the data at the edge of the device. So here, this edge computing we can define in technical terms as a decentralized computing that performs data storage, processing and analysis at the data source. In traditional way, we go for cloud computing. So what is cloud computing? Cloud computing is processing the data centrally. Storage, processing and analysis of the data, everything happens at the center. While coming to edge computing, we are processing, storing and analyzing the data at the source of the data, that is at the data source. So here the data source might be a sensor or else any of the other devices which gives the data to the network. So edge computing is nothing but processing the data near the source. So by using edge computing, we can reduce latency. Here, what is latency? The response time, the time taken to get the response, that is nothing but latency. And it saves the bandwidth. So in traditional computing, what we are doing, we are collecting the data from the source and the data is carried to the cloud. So to carry the data to cloud, we use bandwidth. But in edge computing, there is no carrying the data to cloud. So we can save the bandwidth and we can improve the real-time response. So here, we all the time in our IoT, all the time we depend upon the real-time data. So the data which is changing continuously. So when the data is changing continuously, the responses must be very fast. So that is achieved in edge computing. So here, this shows the difference between cloud computing and edge computing. Just now I have explained. In cloud computing, we will be processing the data at the central. We are having a central storage. There the data is processed, analyzed. But in cloud computing, the data is processed, analyzed at the data source, or else we can call it as at the sensor. So this clearly explains what the difference between cloud computing and edge computing. So coming to the basic differences and what are the pros and cons, or else how we can differentiate this cloud computing and edge computing. Cloud computing is nothing but centralized processing of data and edge computing is nothing but distributed processing of the data. So in edge computing, we get faster responses at the edge. So what are the criteria we have considered to differentiate cloud computing and edge computing is, the first one is latency. Just now we have discussed what is latency. Latency means the time taken to get the response. So in cloud computing, the latency is very high. In edge computing, latency requires very low. So processing power. Compared to the processing power, in cloud computing we have much more processing power, but in edge computing we have limited processing power. Because in cloud computing we have huge memory and we have so many sources and internet dependency. For cloud computing, we require internet, we require a stable internet connection. For edge computing, it is like partially, even if we don't have internet also, we can go for it. And data volume and bandwidth. For cloud computing, we can process huge amount of data, and it requires bandwidth to transfer the data. But in the case of edge computing, it cannot process huge amount of data because the memory is very limited, and we are processing at the data source. So we will have limited memory, limited space, but it can be done. But it doesn't require any bandwidth because there is no data transfer. No need of transferring the data to cloud. Directly we can process at the sensor. And one of the best examples of using of both the cloud computing and edge computing are scalable apps, cloud storage. And for edge computing, it's like IoT sensor data, real-time processing, and all that. And coming to data sensitivity, we can secure the data more in edge computing compared to cloud computing. Now comes the important topic that we are going to discuss is Edge AI. So here I have been discussing the word like embedded AI, Edge AI. So what is embedded AI? What is Edge AI? Edge AI is nothing but applying the ML model directly at the data source. That is what applying the ML model directly at the edge of the network. That is at the data source where the data is collected or where the data is produced. So Edge we can define it as Edge AI is nothing but performing the ML task or else performing the ML model directly at the data source within a local network. By doing this, what we are doing, we are reducing the time, and minimum delay is happening, and we are not depending upon any of the cloud servers. So by using Edge AI, we can achieve faster, smarter, and more responsive models. Now, we'll be discussing one of the best example for this Edge AI is autonomous car. So in auto-driven car, the car can drive on its own. So there is no need of driver. So how this is happening? It means, so in auto-driven car, actually we will be training the model in cloud, and that model will be deploying directly on the car system on board. So we will be directly deploying it on the computer that is present on the car. So whenever the car detects any objects, or else whenever it detects any trucks or any other vehicles on the road, so what happens is it directly uses the local model, and it processes there, and it will take the decision. So here in autonomous car or else in auto-driven car, taking the response must be very fast, because while driving we won't take time. So if the response is very fast, the car will be automatically driving. So to make it possible, we are going for this embedded AI or Edge AI. So here we are having two things. What is embedded AI and Edge AI? So what is the difference is, if you are applying a ML model at the edge of the device, we call it as embedded AI. If you are applying a AI model at the edge of the device, we call it as Edge AI. So here what is happening in autonomous car is, the model will be already trained in cloud, and that is deployed directly on the computer, that is car on board computer. So what is happening? It will detect the objects. Real-time object detection is happening. Here we are terming a word called local AI inference. So here what is inference? Inference is processing the data locally. So here we are applying the ML and AI models directly at the locally. So this is one of the best example. The other example is smart factory, or else we can say it as factory IoT sensor. So in the same way, in factories, by using this Edge AI and embedded AI, we can convert the factory into a smart one. So without any human intervention, we can detect the irregular machines that are working in our factory. So that is, we can detect the irregular machines. So that is one of the best other example for that. Now comes what is embedded AI. Just like that, we have discussed in Edge AI. Edge AI is nothing but applying ML model directly at the edge of the device, or else directly at the data source. Similarly, embedded AI is applying the AI model directly at the edge of the source. So here, instead of going to cloud to process the data, the whole processing, the device can analyze the data, make the decisions in real time. So these embedded models, how the embedded models are running, they are optimized for speed, low power, and limited memory. So how this whole thing works, how it works. So how it works means first the model training, the model will be trained, either the ML model or the AI model that will be trained in the cloud. After training, we will be directly deploying that model to the edge device. So how we are deploying? To deploy, we will be converting the model into the required framework and we will be compressing it by applying some optimization techniques. We will be deploying it. After deploying, the model is run locally on the local device or at the edge device, process the data and it gives the decision. The decision is implemented by using a actuator. So this is how the embedded AI or edge AI works. So how it works means first the model will be trained in cloud. After training, the model will be deployed to the edge devices and the edge device will run the data locally and it will process and the decision will be given. So here what we are doing, whatever the data that is trained in cloud, that is directly deployed to the edge device and that is from that at the edge only we are taking the decision. So how it works? So we have seen how it works. So what are the hardware or what are the supporting what types of devices or else what types of computers are used to run the whole thing? So here we are using a AI computer called NVIDIA Jetson. So what is NVIDIA Jetson? It is an AI computer that runs or is that process the data locally at the edge of the network. So here NVIDIA Jetson is nothing but it's not a normal computer. We call it as an AI computer. So what is the difference between the normal computer and the AI computer? In normal computer, in our traditional computers or desktops or PCs, we use CPU central processing unit. But in AI computers, we use GPU, graphical processing unit, graphics processing unit. So what is the difference between CPU and GPU? It means in CPU, we will be performing the tasks sequentially, but GPU can perform the tasks parallelly. It means what? It can perform n number of tasks at a time. So whenever we are processing the data, whenever we are working on ML or AI models, we need so much of computation. And to process everything in time, we go for GPU. So our AI computers are made of GPU. So one of the best example for AI computer we are discussing here is NVIDIA Jetson. So what it does means it process the data locally within short span of time, that is ultra low latency, and it provides and its performance is very high and since it protects our data. So the main thing is it process locally. We can reduce the latency, performance will be higher and we can protect our data and we can connect this to our sensors. How this end-to-end edge AI architecture with NVIDIA Jetson, how it works means first the model will be trained in cloud. After training the model, that will be directly deployed to the edge layer. In edge layer, we are having our NVIDIA Jetson where the data is locally pre-processed, or we can say it as processed. So after processing the data, we will be getting the decision. That decision is implemented by using the actuator in the action layer. So in the action layer, immediate decision will be taken within a short span of 10 milliseconds, or else there might be any control, any notification, everything will be done. So here in our AI, in the architecture of NVIDIA Jetson, we are having mainly three things. First is that model will be trained in cloud. Later, that model will be deployed to edge layer, and later that will be deployed directly to the action layer where the decision is taken immediately. So again, the same thing, how this workflow happens. First, the data acquisition. The data acquisition is done by the sensors. The sensors will capture the data from the physical world. So the types of the sensors we use, like cameras, lidar, radar, IMUs, all these are the different types of data. That data will be collected from the sensors and that is given to the NVIDIA Jetson. So here the next one is local inference, that is we call it as brain. Brain means where the data is processed and decision is taken. So here the NVIDIA Jetson will process the data on device. How the NVIDIA Jetson will process the data? With the help of the GPUs. the GPU that is on tensor. Here we are naming a word called tensor. Tensor is nothing but a accelerator, AI accelerator. Actually, these tensors will help to accelerate the speed of processing, and it runs the neural networks in real time. Here AI model or ML model, that is nothing but running the neural networks in real time. And so what is the main benefit is there is no data transfer, no delay, and finally the action, based upon the decision, the action will be taken, that is the response. So within very, very short span of time, that is low latency, we can take the action. And what is the final thing? Cloud loop. Again, the continuous learning. Again, whatever the data that is collected, that will be trained in the cloud. Again, from cloud, it will be transferred to the edge. And so here in our NVIDIA Jetson, we will be using few types of AI accelerators. So what is the use of these AI accelerators? They will speed up the processing time. So the NVIDIA Tensor Core, that is one of the accelerator, NVDLA Deep Learning Accelerator, NPUs and TPUs. These are all the accelerators that help in fast processing of the data. So actually we have seen NVIDIA Jetson is an AI computer, but we use NVIDIA AI computers and even we use microcontrollers and SoCs. Why we are going for microcontroller and SoCs means in edge we need a limited hardware. So we are going for microcontrollers and SoCs. We even use AI computers and we use microcontrollers and SoCs. So we use like system on chips. Why we are going for means these operate with low power and they have very limited memory, and we go for optimized models that are suitable to that hardware. And to do everything, we need few frameworks. So what are the frameworks is TinyML and TensorFlow. So TinyML and TensorFlow are the frameworks that enable ML models or AI models directly at the edge with the help of these softwares, that is microcontrollers and SoCs. So these are the AI what is the use of these microcontrollers and SoCs in our edge or else in our embedded AI means to limit the power and we can limit the memory, and we can use this optimized frameworks like TinyML and TensorFlow. One of the best example of using these microcontrollers and SoCs in edge computing is face detection on CCTV and recognition on a smart speaker. And here one of the example of this system on boards is Raspberry Pi. So Raspberry Pi is a family of single board computers. This is used in our edge computing, like the versions of Raspberry Pi 5 that models are used. Now, so what are the, we have been discussing like we will be applying the ML models directly at the edge of the device. So what are the different types of models we use, for which application, which model is used, which type of models are used to process the images, data, and which type of models are used to process the audio, all that. So here we use core ML and edge models, that is they run ML inference on the devices locally by improving the latency, by reducing the latency, reducing the bandwidth and all that. So here we go for TinyML and TinyDL. So what is TinyML and TinyDL? The ML models that can be applied at the edge. Similarly, TinyDL is nothing but the deep learning model that can be applied at the edge. So the next thing is we go for optimization techniques. And here what are the different models we can see, like mobile net, efficient net, TinyML, image classification. So mobile net is used for image classification. Similarly, squeeze net, TinyML net, efficient net, all these are the different models, TinyML models for the edge devices. By using those ML models, we can process the data at our edge computing. So how the whole thing is happening? So to run these ML or DL models locally at the device, we will be using microcontrollers or any of the AI computers. So first we will be training the model in cloud. So after training the model in cloud, that model must be deployed to the edge device. To deploy the model to the edge device, we will be using some optimization techniques. Before deploying the model from cloud to the edge device, we will be using some optimization techniques like model compression and pruning, quantization, knowledge distillation, hardware optimization. So actually whatever the models that are trained in cloud, they are having huge space, they will occupy more space. But we cannot afford that space in our edge. So what we are doing, we are compressing the model by using quantization techniques. So what does this quantization technique do? It compresses the size of the model, and by using pruning we can remove the extra weights, and then knowledge distillation is done. After that we will be doing the hardware optimization. So this is the whole thing done. After training the model in cloud, the model will be undergoing all these types of optimization techniques. So what are the models? We have discussed. The models that we use in our edge are mobile net, efficient net, squeeze net, YOLO, tiny BERT models. All these are the tiny ML models that are used in our edge. After optimization, the model will be directly deployed into our edge device. So before that, what we are going to do, we are using few frameworks like TensorFlow Lite, PyTorch, etol script. All these are the frameworks that we use to deploy and to convert the trained model into, we will be converting the trained model into any of these frameworks so that we can deploy and process the data locally. And so this is the workflow. First the model will be trained in the cloud. So after training the model will be deployed. To deploy the model, we will be following a few optimization techniques like model optimization. In model optimization, we have compressing, pruning, quantization and all that. After applying the optimization technique, we will be deploying the model. To deploy the model, we have to convert into any of the frameworks, like we have to, it might be a TF Lite, ONNX, Torch, PyTorch. All these are the frameworks in which we have to convert the model after deploying from cloud. After converting our model into any of these frameworks, we will be finally processing locally. Taking the real-time decision we can take the decision immediately. So this is how the whole thing works in edge ML or else in DL. First, what is happening is we will be training the model in cloud. After training the model, we have to deploy it into the edge device. So before deploying, we will be applying the optimization techniques like compression, pruning, quantization, knowledge distillation, and architecture simplification. After that, we have to deploy into any of the frameworks we have. Here we are having the frameworks like TFFlow, PyTorch, ONNX, Runtime, MediaPipe. All these are the frameworks in which we have to deploy our model. And after deploying, we will be processing the data locally, real-time inference, and the action decision or the action will be taken immediately. And we have few challenges for all these models. And so we have seen how the whole workflow works for embedded AI and edge AI. So these are the examples of embedded AI in our daily life where we are using these embedded AI. So at first we use in industrial automation. So in industrial automation, we use to analyze the inputs from the sensors and we locally predict the failures of the machine, and we optimize manufacturing process in real time. The next thing is we use it in healthcare devices like wearable and portable medical devices that interrupt with the biometric data and give us the instant, immediate diagnostics. And even we use in our smart home products devices like smart home thermostat, security systems, learn using behavior patterns to act autonomously without needing a constant cloud connection. And even we use in consumer electronics like smartphones, digital cameras, which run on device AI for facial recognition, voice assistance, automatic scene understanding or else for photography. And what are the benefits of embedded AI? So what is the main benefit? We can take the real-time decisions, we can reduce the latency, we can protect the privacy and security of our data, we can resilience. Devices remain functional even if we are not having any internet connectivity. It means without internet connection also we can run our model. And it is cost effective because we can reduce the cost as there is no bandwidth. Bandwidth is saved, so cost is reduced automatically. So the examples of embedded AI is first is industrial automation, healthcare devices, smart home products, so whatever the robots we are using all run on the basis of embedded AI. And the last one is consumer electronics, smartphones, cameras and other devices. Here I would like to conclude my topic. Thank you.